Recording is on.
Here we are.
Hi and welcome to the May edition of the Uyuni Community Hours. I'm Marina and today I will be your host for this session. In the background there is also Pablo helping with the recordings, so thanks Pablo. For today we have a quite rich agenda, and I will start with an introduction about some things, I don't want to spoil too much, that are happening these days. Then we will introduce our mentees for the Google Summer of Code, and we will see an overview of their projects. And then we will go with two additional technical presentations, one from Jan, about the autonomous patching agent with the Uyuni MCP server. And the second one will be from Marvin about the GPG management and distro upload with the MGRCTL API. So let's get started. Well, first of all, there are some news that we want to share. And the first one is, well, a big anniversary. So officially announced on the 26th of May, 2018, we can celebrate the 8th anniversary of the Uyuni project, so our project, our community, and yeah, it's worth to keep in mind this big achievement. I mean, 8 years of great work and community interactions. So, well, in this case, I should say happy birthday to all of us, given that we are all part of the community. If you the date of the establishment of the Uyuni project, actually everything started a little bit earlier, on the 18th of May, but I mean, the official announcement is May 26th, so this is when the project can be officially remembered as established. So let's keep up with the good work and let's continue to work all together. And always talking about our community, there is another reminder that I want to share. So this year, the OpenSUSE conference will take place again in Nuremberg at the ZBAU from June 25th to June 27th. And the important bit is that we are there as also as a Uyuni project, not just as OpenSUSE members. And we have a few sessions. And one in particular should be relevant for you. I mean, also the others, but the second one that you see listed are the community hours. So the next appointment that we will have, it's not just happening live on Jitsi like now, but we will have a session that will be also in person in Nuremberg. We will have the live. So please, if you are around Nuremberg, try to join us directly there. It would be nice to see you in person. And of course, this is about our community. So if you want to present something, if you have an idea that you would like to share with the community, please let us know so we can plan the topic directly in the agenda of this appointment. For what concerns the other presentation that you can see, on the 25th, so the same day, we will have also a presentation from Pablo about the Git workflow and what is going on. You saw already something during the previous community hours, but of course, this is a topic that is ongoing, is developing, and there are always additional information that will be relevant for all of you. Then, as I mentioned before, we have the community hours, always on the 25th. So the very same time slot that we are used to meet. And then the last session will be on the next day, on the 26th, will be from Michele, and will be a presentation about running Uyuni everywhere. So from bare metal to cloud, you know, the usual way to run Uyuni, and Michele will we'll talk about we'll talk about this. From the links, you can see the details of the proposal, but in any case, if you go to the conference website, you can register. Please register if you're attending. And yeah, I hope to see all of you there. Then moving to the other big topic of the day. So we have the Google Summer of Code, and we have some of our mentees directly in the call today. And this is for sure the good moment for saying again, once again, welcome to the Uyuni project, to all those new contributors that are starting to contribute to our project. Now, if you don't know what is the Google Summer of Code, I will give you just a quick overview of the project and how it works. But in general, the idea behind the GSoC is to provide a framework where new contributors can have paid time for starting to contribute to a project. So having, being in touch with what means be part of an open source project. And I mean, it's not just about development, but it's about developing and at the same time learning how to be a good community member. The project is organized, spread across several weeks, and this program from Google is focused on development. In the past, it was open only to students. Since a few years, actually, the requirement has been readapted, and it's possible to participate being, of course, at least 18 years old, but let's say that it's a project for beginners in open source. So people that are involved in open source for less than 2 years, less or more, or in any case, students. The program is a global one. So there is also this additional opportunity to interact with an international team. And the projects are divided into 3 different categories. Small projects, about 90 hours of activity, of work, medium project, 175, and large projects, 350. Of course, those mentees are not employees working full-time on a product. It's not this the idea behind the GSoC. And it's also a mentoring activity, and this is also why every mentee has one or more mentors assigned that will help that will guide the mentee during this coding activity. And at the end of the project, of course, the hope is to achieve the goal of the project. Can also happen that maybe a project is reiterated in more phases during several years. That's also possible. And of course, for the Uyuni project, this is not the first time we are participating, always under the OpenSUSE organization. But yeah, I mean, there are a lot of improvements that have been done to our project, thanks to the contributions of the GSoC mentees. And for giving you an idea, it's called the Google Summer of Code because the coding work is happening between end of May and let's say August, mid-August. But of course, there are some phases before and after, because apart from the organizational stuff that is also usually happening at the beginning of the year, there is what is called the bonding phase, where the accepted projects with the accepted mentees are starting to get in touch with the community they will contribute to, and that they start to get familiar with the community. And today is May 28th. The coding phase started just on the 25th. So we have several projects for Uyuni for this year. Of course, they are just at a super early stage because all the mentees just started to work these days, really focus on the projects. The ending deadline, of course, can change according to the size of the project, but in general, unless there are some specific extensions, all the projects are ending with all the evaluations, I mean, around the beginning of September. And in some cases, this deadline is moved to November. So as you see, it's the summer of code, but actually it's something going on that takes the full year between organization and real coding activities. With that, I want to give you the overview of our projects for this year. We have some of the mentees directly in the room, so I'm not going to tell too much about the projects. In any case, from the links, you can see also the details of the project itself. But this year, and let me do a step back. I will try to pronounce names correctly. Please forgive me if I'm messing up something. I will do my best. So we have Akash Kumar that will work on evaluating cloud-native storage performance benchmarking for Uyuni and K2. Then we have Giti. Okay. I did it before and now I'm messing it up. Gitansh, I hope, Goya, sorry. Also, you are in the room, so please forgive me again. That will work on a project that is called Uyuni Event-Driven Automation via MQTT and Node-RED. Then we have Jay Prakash Katara, that will work on kubecontrol like get command for mgrctl. Then we have always here in the room also Dick VJ, okay, Dick VJ Ravat. That will present, that will work on AI-powered intelligent monitoring and root cause analysis for Uyuni. Then, always in our room, Imanshu Jaiswal, that will work on Uyuni, migrate API documentation to Open API Swagger, and Surya Srinivasan, that will work on native LDAP authentication with RBAC mapping in Uyuni. Now, since we have some of our mentees here, first of all, again, welcome to our project. And maybe we can just start from DPJ. Do you want to tell us something about your project?
Hi everyone. Let me quickly share my screen with everyone. Is my screen visible to everyone?
Yes, it's visible.
Uh, so hello, my name is Digvijay Rawat, and today I will be presenting the AI-powered intelligent monitoring and root cause analysis for Uni. This project focuses on improving infrastructure monitoring by combining traditional observability tools like Prometheus and Grafana with AI-driven analysis. I am currently working on this under the guidance of my mentor, Oscar and Jody. So, before diving into the project, a quick introduction about myself. I am a second year undergrad student at the Indian Institute of Information Technology. I started contributing to open build services from November to February, and that was the front end part of the OBS. And then later, I became a member of the OpenSUSE. Here are my tech stack. I have been working a lot with the LangChain and LangGraph a lot recently due to the AI agent which I'm building. Uh, so, first, let's understand the actual problem which the current infrastructure is facing. So, currently, Uni involves monitoring a diverse range of Linux distributions like Debian, Ubuntu, OpenSUSE, and the Red Hat based systems. But now tools like Prometheus and Grafana are actually very good at collecting matrices and visualizing them. But the real issue is that they mostly provide raw data in forms of logs. For example, they can tell you CPU uses is 95% or memory uses crosses a threshold, but they usually don't explain why it happened. During production failures, system administrators have to manually investigate logs, processes, and services to find the actual root cause behind the failure. And in critical situations, this process becomes slow, stressful, and expensive. So, the core problem I am trying to solve is how can we transform raw monitoring into actionable intelligence. So, to solve this problem, I am designing a AI monitoring agent for Uni ecosystem. Here is the diagram which represent the whole agent in itself. So the agent is a containerized Python. It will be a container. So the agent collects the uh, matrices from the Prometheus, and it will calculate how what is the threshold which we are reaching. If any anomaly is detected, the agent will use the salt tools to uh, to run salt commands on the salt client to see the actual cause of the issue, and then after it has successfully collected all the information, it will send sub messages to the alert manager. Here in alert manager, we are trying to make some custom alert templates so that the alert messages can be made for emails, telegram, and slack messages to give the alerts to the system administrators. So the high level architecture is the ingestion of the logs, detection of the detection while calculating the threshold, intelligence, and alerting. Here is a diagram which can easily tell the whole process. The If the agent feels like there is some anomaly in the system, like for example high CPU usage, or given the memory uses, the agent will go to the prompt collector, and because here the CPU uses is high, we will give a specific CPU prompt with the system prompt, and then we will get a full prompt which will be given to the agent. Now the agent, with the help of various tools and technology, will summarize and give a root cause analysis of the whole process. It would be sent to the alert manager, and the team could be informed about the issue. This process is very fast um, due to the automation the agent is bringing. So, for technical details, the agent will use the React framework. So, the React framework is built on top of the React paper, which the Google AI Lab has presented. So the React framework is basically the agent will continuously learn from the tools which we will giving to it. Here is the start of the agent. The agent will start here, and then it will use the solve tools. This loop will continuously uh, will run till the agent is confident that the output is uh, like the reason is cleared behind it. um, this is the expected outcome the team can expect. Here I tested it using a stress command. It just raise the memory uses in a salt client. I was using the Quen 332 billion parameter model for the testing, and this is the output the agent has produced. The agent produces a summary with the server. Basically, it will be a IP. I changed that to a name at the start. Value, the root cause, why the process, why the what is the anomaly, everything about it. The remediations, how can we, what can we do to stop the root cause of the anomaly, and the evidence why the agent thinks that this is particularly the reason for the anomaly. This part will help to avoid hallucinations in the later part. So the goals of my projects are containerized Python AI agent, Salt tools integration, custom AI templates, and full testing and documentation of the full project. The timeline I am expecting is like uh, um, at the 20. After 1 month, I am confident that I can uh, give that, or I can be done with all of this. That's conclude my presentation. Thank you everyone for listening. I would be happy to take any questions.
Of course, we will have some additional sessions about all the projects. So maybe if we don't have questions now, don't worry, because when we will have the next presentation, we will have more details, and maybe people will start to also use your project, and I'm pretty sure they will ask you more. In any case, thanks a lot, and thanks again for deciding to contribute to the Uyuni project. So welcome again.
Thank you, Marina.
Okay, then I would say let's move to the next one. Maybe Gitanoj, do you want to go next?
Hey Marina, hello everyone. I'm Gitansh, currently pursuing my engineering studies and actively contributing to open source communities. My project is called Uyuni Integration with Automation Platform, with my mentors Andrej and Abid. So if I talk about me, I'm a currently first year student pursuing my BTech journey from Newton School of Technology in India. So now coming to the problem statement, currently automating workflows in Uni requires manual scripting and continuous API polling, which cause there is no real-time event streaming system or easy low-code automation platform available for administrators. Because of this, the infrastructure automation becomes more complex and time-consuming. So I propose a solution, like my project, which introduce an event-driven architecture for Uni. Uni events will be published using MQTT and consumed inside the Node-RED workflows. This allows administrator to visually create automation pipelines and drag and drop workflows. If we like think about the architecture overview, the Uni generate the events, then it will move to the MQTT broker distribute. Then the MQTT broker distributes them, then the Node-RED process them. These workflows can trigger your Slack alerts, your Jira tickets or emails, or like automated remedial actions. The key components will be for this project will be the MQTT event publisher, Mosquito MQTT broker, and a custom Node-RED modes. Uh, If we are talk about the community impact, this project helps transforming Uni into a modern automation platform. It reduces the manual effort of admin or like enables scalable integration with external DevOps tools. So, like if we talk about future scope, in the future, this architecture can support AI-powered monitoring, Graphna integrations, secure MQTT communications, and more advanced automation workflows. So, this is all about my project and the solution I'm building. I'm really excited to contribute into the open source and Uni ecosystem through this project.
Thanks indeed. It seems really an exciting project, so can't wait to see it in action. Thanks again, and thanks a lot for joining our community, and welcome again.
Thank you, Marina.
And maybe Himanshu, do you want to go next?
Yeah, sure. Okay. So I'll share my screen to you guys. I hope it's visible.
Yes, I see the slides I'm sharing.
Okay.
Okay.
So hello everyone. First of all, I'm Himanshu Jaswal. I'm very excited to be a part of the Google Summer of Code 2026 with the Uni and open source. My project is focusing on modernizing current Uni API documentation. So by migrating it from the legacy Java doc-based system to an open API Swagger annotations. I'm working with the guidance of my mentor, Welder. So today I will briefly explain myself and about my project. So I'm Himanshu Jaswal. Currently, I'm a third year BTech undergrad from India. So, as well as I'm a previous year GSoC contributor in the different organization that is a Scala Center. I'm primarily interested in a backend system and distributed architectures, API, and developing tools. So, and also passionate about open source software development by improving developer experience through better tooling and automations. So, that is about me. So let's talk about the problem statement that exists currently. So currently, Uni API documentation is rely heavily on legacy Java docs. It passes into the custom doclet, and it will result some. The output is ASCII, DocWork, HTML, JSP, and different type of documentation. But it's a historical approach by the Uni, so it creates several challenges for us, like inconsistent documentation and no compiler validation. So it which makes I guess that maintenance difficult. And secondly, there is no strong validation mechanism to ensure the documentation APIs actually matches the real server behavior. So because it's a static system, right? So so legacy Java doc plus custom doclet may be fragile and hard to maintain. So and also it not matches the current modern tooling and currently technical standards. So it's better to remove this, and integration with the modern tooling may get difficult due to this historical approach. So my project goal is actually the concept I'm thinking about by my mentor Weldo. He invented this. He thought to convert this into the Uni Open API, where the Java doc get a real single run transformation into a Swagger annotation. It's a one-time go, and then it can pass to the Swagger parser custom, and it will result to the Open API spec. With some contrast testing, it validate Open API spec, and finally it results is to the different type of documentation, which it's modern, based on the modern tech standards. So it's a very good thing. And then a custom Swagger API reader generates the daytime driver specification. So yes, this approach is maybe modernizing the entire documentation testing and pipelining while preserving the compatibility with the existing workflow that exists in the Uni. So my plan is to deliver this into the four major areas. I think it's so to first of all migrate the current 60 plus API handlers, as well as building docbooks parser, enhance Swagger UI ASCII doc, and expand the contrast testing as well. I also created a plan for it. Like, I created a website for this API handlers migration. I'll show you guys like this. In this, I have the total thing that how much API is currently translated or no migrated. Like, I have the status area. Like this, my currently this proof of concept. Like, my mentor did it partially about some namespaces are already migrated, and some are not migrated. Like this, I have the list of API and the namespaces. So I'll update it as soon as the overall migration process goes down. So it will show the current process progress of my project as well. So it is built by myself. It will help me and as well as my mentor to look into the project along this summer. So let's back to the problem statement. Yeah. So as well as we would think to build different parsers for the current different type of documentation outlets. So we will also look into that in this project. And as an expected outcome, I believe this project can significantly improve the developer experience around Uni APIs. The new system will provide an interactive and machine readable documentation through the Swagger UI, and while reducing the maintenance overhead for the maintainers. So yes, it will improve the consistency as well as an API governance, because the open API specification becomes the authoritative contract, I guess. So yes, so from my side, the project is also huge, but it's a very good learning opportunity for me as well. So I'm looking forward to gaining a deeper experience in the large scale Java backend system, the open API tooling and documentation pipelining, and how enterprise grade open source collaboration will be done. So it will be a great project for you guys and me as well. So thank you for me to being a part of this uni and the more open source community. And thank you for giving me this opportunity in this GSoC. Thank you so much. And I like to take your questions if you have any.
Thanks a lot, really. Also, a big welcome to you. And yeah,
Thank you.
definitely looking forward to the outcome of your project. Welcome again.
Thank you so much.
I see in the call also, Surya. Maybe you want to go next.
I'll go. I'll share my screen. Is this my screen visible?
Yeah, at the moment I see the slide I'm sharing.
You could see these slides, right?
Yep. Okay.
Yeah. Okay. So, yeah. Hello, everyone. I'm Surya Sinivasan, and I'm a final year CS student from India. So, to talk about my project is about adding a native LDAP authentication with role mapping support to make authentication easier to manage directly from Uyuni. So, I'll be working this summer with my mentors Andrej and Abid. So, to talk about myself, and I'm mainly interested in backend system and distributed systems and infrastructure related works much more. And apart from this, apart from this OpenSUSE, I've already been like contributor in the Apache as well, and also from the MDN. And currently, I'm in this OpenSUSE as well. And to talk about the problems that I'm gonna solve in this summer is that one, yeah. So right now the problem is that the LDAP support exists, but mostly it depends on the host level setup using PAM and the triple ST. So that means the admin often needs to manage authentication outside ONE, which adds manual work and makes centralized management harder. So there's no single place to manage it. Authentication setup lives on each host, not inside Uyuni. So it's hard to audit or change. By end of this project, we will be having the native LDAP where we can able to change everything in a single place. And apart from that, right now, even though the LDAP exists, the Uyuni is not directly contacting it. It's contacting through PAM and triple ST. And even though if it contacts, it only receives whether the particular user is there or not, whether it's the login is successful or not any information about the groups or roles. So what this project solves is that it will directly contact the LDAP and it will also receive the information about the groups as well. So through that, can able to reduce lots and lots of manual work that's been done right now currently in the uni. So about the process, how this project will pan out in this summer, and to talk about that, most of like till now the process remains same, and I also ensure that all the process, how the authentication and the login process works remains same. But to my project, to solve the issue currently, what the uni does have is by having an additional layer, or kind of having an abstraction layer apart from all the authentication provider that's already been existing in uni. So like you can see the blue one, it's the one I will be working on this summer, to add a separate abstraction kind of layer, or I could have the separate method inside the login controller to solve this problem if a particular user logs in through LDAP and wants to change through the UI of the uni itself. So apart from that, like till now, like this community period, I just already completed most of the work about how should I start by this. I mean, already the coding period started, and till now, these are the things I've already set up.
Sorry, yeah. The screen sharing is not working. I don't know if you stopped it on purpose or if it crashed. But at least I don't see your screen, and I see also Dominic was raising his hand, so I suppose.
Oh,
Okay.
now it's back though for me.
Yeah, now it's back. Not so for me. Uh,
Thanks.
It's okay. So it's right now
okay,
it's visible, right?
sorry. Yeah, now it's visible. Sorry.
Okay. So I think I stopped where I'm right now, right? So like through this community period, like my most of the work has been so far has been set up and understanding the complete system around uni. So right now I already set up the local environment, and like you could see, I've already set up the local environment, and just understanding how the complete authentication communication works. And also apart from that, I also explore the complete authentication flow, worked with the LDAP fixtures, which I'll be working on this summer completely. Also explore the complete client and the server communication through the salt channels they have right now. And apart from that, I also started to draft my RFC as well to proceed with my project. And yeah, so for at the end, the next steps are finalizing the decision, and as I said, with my mentors, and then I'll be working on completely to just proceed with my project. Yeah, that's about the project, and I'm pretty much hope so that I'll be completing everything what's I've been mentioned in the proposal right now. So yeah, that's about my project, and looking forward to collaborate with the this community. That excites me more. Yeah, that's about it.
Thanks a lot. And yeah, of course, happy hacking also to you, and welcome again to our community.
Thanks.
Then I was looking up before at the list of attendees. I think we don't have the other two mentees, unless I'm missing someone. I think no. Then, in any case, we will have an update on all the projects and how they are progressing in the upcoming community hours. So stay tuned. And I would say, if you don't have any question about the GSoC, I think we can move to the next topic. Okay. So, Jan, he wants to present us the autonomous patching agent with the Uyuni MCP server. So, the stage is yours.
Thanks, Marina. Okay, let me quickly share my screen. So, hi everyone. My name is Jan. So today I'm going to share with you a example application of our MCP server, which is intended to act as a simple framework on a specific way of designing agents for emphasizing especially enterprise workflows where auditing and guardrails are absolutely critical. So I have a couple of slides to share. It's not a full slide deck, but just a couple of pages. So let's go with that. So what is this about? So it's going to be a LangGraph-based Python executable agent. So you can plug this into any kind of agentic runtimes as well, or this could be just run as a standalone script. So the scope of this agent is to do a small maintenance wave inside a much larger fleet. So it's not going to patch every system, but it will involve some kind of decision making into picking some small defensible maintenance waves. How it does this is via first using the MCP server, it will gather the information about the systems and inspect the scope and summarize their patch exposures. And then the LLM will propose a narrow wave down to system level when needed. So imagine if you have some critical kernel updates which bring significant risks to the workflow, it might just propose a to patch a single system as a canary, and then move on from there. Or if in another patch cycle, if there are just some user space updates which are not super critical, it might decide to go with the whole system group. And then most importantly, it will validate all the proposition against hard policy. And at this step, we keep the behavior deterministic. And then finally, it will pause for a human approval. And then once approved, it will schedule all the updates via the Uyuni's MCP server. So let's talk about an example scenario. So let's say we have a maintenance window that targets two approved system groups, DMZ gateways and internal file servers, each having a few systems inside them. The fleet is mixed in this case, so patch exposure is not the same across the group. So there might be some Red Hat-like systems here. There might be some others with SUSE systems. So not every system has the same patches available for them. And like I mentioned before, the agent should not blindly patch everything in one wave. So it should look at the data and propose a defensible first wave, let's say. And depending on the situation, it can propose to patch the whole group at once, or a smaller system level can reset, like I also mentioned. And then it must justify the selection to the operator with the rationale, and then wait for its approval. So the architecture is quite simple, actually. So this, like I said, the important points here is to where the control begins and ends. So how freely LLM can move within this agent. So is the critical part. So if you look at this architecture, we start from the left side, the LangGraph application, which is the agent. It has the connection with an LLM, and then it communicates with the Uyuni using the MCP server. And of course, our MCP server is also protected by OAuth, so we have an external identity provider in the picture. Both the MCP server and Uyuni authenticates the user individually with the identity provider. So in every step of this chain, the requests are authenticated. And next, in a Uyuni or multi-Linux manager in this slide, we perform the operations, plus we keep everything audited, including who did this change, on behalf of who, and what happened, what are the results, and everything. And finally, the Uyuni schedules the updates for each individual system, and then they perform the updates themselves. Um, uh, so the patching workflow works like this. So first, like mentioned, we resolve the requested target groups, the system groups, and we query the MCP tools to summarize the patch exposure. And then we send all this data to the LLM to propose us a conservative wave. And then we validate the selected groups and the system IDs deterministically. That is the output of the LLM. So it makes the decision and it comes back to us, and we deterministically check if everything is in order. So this is another critical part in enterprise setups. And then finally, we pause for human approval. And then once the approval is given, we schedule the updates and hand off to a follow-up end of follow-up to a later observer step. So that is once you schedule the updates, as you know, this is a updating. It takes time. The clients update in their own times. Maybe sometimes, in some cases, they need to reboot and everything. So the checking of health check of the systems after the update belongs to a separate step. Um, so before a live demo, let's check a little bit. So let me try this again. So I have a Copilot instance here. I'm just going to create my system so you can see what systems I have registered and what's the current status. Let's go with this one. So this Copilot instance is connected to the Uyuni MCP server only.
Can you
And
increase the size a little
sure,
bit, please?
yes. Is better or even more?
Yep, thanks.
So yes, I have 4 systems defined in my Uyuni instance now. So these first two systems belong to the DMZ group, and the other ones belong to the file servers group. And as you can see, 2 of these systems have multiple pending updates, and the other 2 are up to date. Um, Another thing relevant for this is what system groups do these systems belong to, because the agent also works with the system groups. When you are running the agent, as part of the input, you give it the system groups that it needs to work or needs to consider. So for example, you might have a maintenance session only involving the DMZ gateways, or you can have another maintenance session involving all the systems in the whole thing. So that depending on that, you would specify which groups this should work on. So this is all the information I have. Now I'm going to run this agent, and then I will go through a little bit a few essential parts of the code. So how I run this. Let's see. So the first thing it did is it authenticated with my Keycloak instance, my IDP, and now it's getting all the required information using the MCP server, which is the patch summaries, the types of these patches, and getting some examples of descriptions to be able to make a decision. And now it gave me the result. So as you can see here, first it gave me a brief. So this brief is generated by the LLM with all the data we provided it. So you can see that it's mentioning that DMZ2 and FS2 are the systems that in need of updates. So you can see a more detailed summary here. So in the next section here in the rationale, this is the explicit question that we ask the LLM: why did you make this decision? So this is important to brief the operator who is going to approve this whole thing. And finally, in the end, we have the selected systems to update. So when I go ahead and approve this wave, I need to provide a little bit more information. Who is this operator who made this decision? Let's see, me. And we also need some notes, especially in the case if you reject this. We still need to put in some notes, so everything will be audited. So why was this rejected? You can just go back and figure out. And once I approve this, it is going to schedule all the pending updates for the system selected. Now it doesn't successfully do this because my systems are not running right now, they're down. But imagine after this step, it'll just schedule the updates and then get back with the action IDs for a follow-up step later. So next, I want to show you a few details on this code, because so this project is not intended to be used as is, but rather it's more like a framework or a guideline to how to implement agents in an enterprise environment where, like I mentioned earlier, uh, where we don't want to give up the whole control to an LLM. So the easy way to do this would be, just dump all the data to the LLM and say, update these systems for me. Then what happens is that the LLM will start considering the tools in its disposal, and just with full autonomy. But then we know the usual problem. So I mean, what happens is it can hallucinate, it can go out of bounds, and you don't have control about what's been done. So you just ask the LM to update a bunch of systems in the system groups, but you end up in a very different place. So there needs to be some hardly enforced guidelines here. So I am so yes, okay. Here's the full code for the for just what you just saw. A couple of things. So this will be mostly relevant for if you are familiar with LangGraph and Python, but I can quickly show you how I set this graph up. So I think it's the best place to start. So as you might know, LangGraph it works as a like as the name suggests, it works like a graph, a state machine. So you start from an initial state, and you conditionally switch over the next state until you arrive at the final state. So if you look at here, I'm adding all the nodes and the edges of this graph. So what we do is first we resolve targets, and then we collect the errata, and then we summarize the system groups, and then we propose the actual selection. The LLM proposes the actual selection, and then we validate it, and then we draft a plan. The texts actually you saw on the screen, and then we hit the approval gate, where I need to input a yes or no, and this extra step checks if we have auto approve enabled, which wasn't in the latter case, and then finally we schedule the wave and record follow up, or we cancel the wave. And here are the edges that connects these nodes. So another important thing is I here on top I have a data class called patch state. So this data class holds the information for everything that the agent does. For when it's transitioning from one state to the other, every data collected or provided as an input or generated in some intermediate step, they're all kept here. And the trick is, this is a single patch state object is passed from state to state. So resolve target state picks up this patch state, and in the end, it fills a little bit more of this patch state and hands it over to the next node and next node and next node. So in the end, you will have a full have the full data of what agent is operating on. So to keep it short, I'm going to just pick a couple of nodes and show you how they work, because those are the critical ones. For example, let's start with the proposed way. So first three, okay, let me start with collect errata.
Can you increase the font size a little bit?
Oh yes, sorry, I always forget this. Is it enough? I hope so.
It's
Okay, so yeah, let's start with this one, the first node, which is the resolve targets. So to resolve targets, we need to use a tool from the MCP server. But the key point I want to mention here is that we are not even asking the LLMs to pick the tools for us. So this is on purpose. It's a very strict application of LLM. So the LLM itself is only involved in the actual picking of the systems, making a selection, and also preparing the text to brief the operator. Other than that, all the other parts of the agent are fully deterministic. So here, within all these boilerplate code, I want to show you where I call the tool. So here, when I need to get the list of systems in a group, I just tell the MCP to call this specific tool with these specific inputs. So LLM is not making a tool decision here. And once I gather all the targets and all the also the patches and everything, the first part where LLM is actually involved is this propose wave step. So what I do here is the most of this bulk of this code is just collecting the data, transforming the data, putting it into a nice structure. But in the end, what's relevant here is where we generate the prompt. So in contrast to usual chat UI prompts, this is a structured prompt in JSON, which means you can send the whole JSON object to act as a prompt here, right? So the important parts here are the constraints that we try to enforce, and then of course, the natural language instruction. And here I also ask it the actual shape of the data that needs to be returned, because then I will transform this data even further and um, use it next. So I invoke the LLM here with this prompt, and I get the list of systems. From there, you can. I already mentioned, so that we have this policy constraints here, trying to enforce our workflow policies. There's only 3 different items here, but it can be much bigger in a real life scenario. But the thing is, once you put these policies like this in an LLM prompt, it's no guarantee that it'll follow them, right? So it's still in LLM's discretion to ignore these or apply this. So in the next step, for example, after the propose wave step, we have an explicit validation step, and this step does not involve LLM at all. So even though we ask the LLM to stay in the boundaries, we still check every boundary deterministically again to make sure that we never go out of the policy, which is another critical thing in this kind of workflow. And finally, the rest is actually self-explanatory. So draft plan is where we ask the LLM again, this time just to prepare the operator brief, the text that the operator will see. Then after that, we have a interrupt call, which is a feature of LangChain that's for this human in the loop kind of things. So this is the approval gate that the also in the example run you see in the yes no answer and the additional data that we provided there. And after that, we hit the schedule wave step. And in this step, we again call a few additional MCP server tools. Again, we pick the tools here. We don't ask the LLM to figure it out and run the tools. So we run the schedule updates, and in the end, we gather the action URLs of the events that are created, so we can follow up later. One final thing I wanted to mention again, if I can find it. Never mind. Okay, so we are actually super on at the end of our time. So and I think I showed everything I wanted to show. So again, like I said, this is intended to be as an example for such frameworks that you still need some deterministic control over what you are letting LLM to do. And for example, this is like a bare bones example, even though the code seems a little bit fat, but that's all formatting and text and everything. So the thing here is what we are providing the LLM to make a decision is quite simple, actually. What we give it is a list of patches, list of systems, list of groups, and we're asking it to infer maintenance patching wave out of this information available. But in a more sophisticated scenario, you could actually integrate this with separate agents, for example, just to make better informed decisions by providing this additional agent with some extra tools. For example, you can define to your LLM some extra MCP servers, like I don't know, it could be a CV database, or it could be some web search access, or some internal company resources for it to make even better decisions. And on top of that, another integration possibility is, of course, so this is just a Python executable. It's easy to run. You can run it from everywhere, but it's not very super useful if you have to open a terminal and run this from a terminal window every time. So another good opportunity for integration here is that you can, for example, integrate it to any kind of change management process. So like you can integrate it to Jira, you can get the responses or this text even on Slack. So as long as you have a mechanism to provide your approval, this can be integrated anywhere in an ongoing much larger system. So yes, I think that's all I wanted to share today. So do you have any questions?
It doesn't seems to be the case. And check the chat. No, nothing in the chat. So I would say thanks a lot, John, for the presentation.
Thank you. Let me stop sharing my screen.
Okay. Then, looking at the time, we had in theory one more presentation planned, but we are definitely over time, so maybe we can reschedule it for the one of the upcoming sessions, so we are not squeezing in what Marvin wanted to present. With that, I would say again, please remember that for the next community awards, we will be directly live in Nuremberg. So please, if you can join, would be great to see all of you in person, or at least who can travel to Nuremberg in person. And for everyone else, if you want to present something, that will be a special edition focused on our community. So if you have anything that you want to present, please let us know so we can plan the schedule. Will be always 1 hour, so that is the limit. But yeah, I hope to see you there or to see your proposals. Any last minute comment, feedback, question, anything that you want to share with us? Then I would say thanks a lot for joining, and see you next time.
Bye. Thanks.
Thank you.
Bye.
Bye bye.
Ciao.
Nice. Yeah. Bye bye.
Bye.